Hello, my name is Ali Sekman. I'm a professor of computer science at Tennessee State University. In this video, I'm going to explain generics in Java. They are pretty useful, and I hope you enjoy the video. Okay, so I'm going to write a couple of codes just to make sure that you're motivated for the need for generics. First, I'm going to go to Visual Studio Code. I have a folder, learning folder. I open it. And then I add a file called test.java. Okay, so let's remember what we discussed about collections. We had set, and set is a collection, in other words, a data structure that can hold items, but you cannot have repetitive items. In other words, you cannot have duplicates. Set was the interface, and we had three implementations. One was hash set, the other one was linked hash set, and the other one was tree set. And tree set inherits from or implements sorted set. The difference between hash set and tree set is sorted, hash set is not sorted. So let's go ahead and create a class. I just have the backbone. I have a class test, the main method. I'm going to go and create a hash set here, set. Let's say my set is equal to new hash set. Okay, so remember, hash set is not sorted. Then I go and say my set dot add. For example, I can say TSU. I am adding a string. Okay. And then I say my set dot add. I can go and add another string. I can say computer science, for example. Okay. And then I can go and add another one, my set dot add. For example, I can go ahead and add what? A new integer object like this. And I'm going to tell you something here. And Java is going to strike through integer, because integer class, this kind of calling the integer constructor is deprecated. So what you should do, you should just call as 20. 20 does not mean that 20 is like int primitive data type. What Java does, Java has auto boxing. First creates an integer object and initializes it with 20. Okay. So I have this. Let's say that I want to print my list or my set, sorry. Okay, so let's see. I'm going to bring terminal here. Okay, right here. And then let's clear the screen. And I say Java C test.java. Okay, all right. Of course, there's a mistake here. Let's fix it. And then let's compile again. All right, so it compiles. Don't worry about this warning there. I'll explain that later. And then let's run it, Java test. All right, so it prints 20 TSU computer science. And the ordering was random, if you remember. So here is the question to you. So I have a set, and I am able to add string and what? Also integer into this. All right, so I'm going to make a little modification. What about if instead of hash set, I have tree set? Will this be okay? Can I do that? I will not be able to. It's going to compile. Let's go ahead and run it, compile it. It compiles, but when I try to run it, it's going to throw an exception. Remember, tree set was sorted. In order to be able to sort elements of a set, they must be of the same type. So you have two strings and then one integer. Java is going to complain about it when it tries to run it. Okay. So how can I fix this issue? How can I fix this one? How about if I put here, because I don't want it to compile at all. I don't want to crash. I don't want it to crash, but I don't want it to compile at all. So it should warn me, hey, you cannot have integers and strings together. So I'm going to go put a keyword here, string, okay, and here I will put string. So I'm using the generic type now. So as you see, immediately this is underlined. If I do that, I'm telling Java that I'm creating a set, 3 set actually, but it can hold only what? Strings in it. So I can add this one, I can add this one, but when I try the 20, let's compile. Java is not even going to compile and complain. So one use of generics like this is to make sure that we have stronger type check. So at compile time, it can catch the errors or possible problems. Okay, so I'm going to change this example to something else. Let's say that instead of those, I have a list. I say list, okay. Let's say my list is equal to new. Let's assume it's an array list. I do that, okay. So I created a list, I call it my list, and I'm gonna go and add an element to the list. I will say TSU, for example, and then I'm gonna go and add another one, my list dot, okay, I made the same mistake here, all right. My list dot add, and then I say computer science, let's say. So this is perfectly okay. I added 2 items. Both of them are what? Strings. And then I say string str is equal to, let's say that my list, okay, dot get, my list dot get 0. So my intention is, first of all, if I go, let's get this one off. If I go and say system.out.println and then my list, let's see what's going to print. I'm gonna go compile and then I'm gonna run it. So it prints TSU and computer science. Okay, so that's what my list is. But what about if I go and try to get the first element of the list, which is TSU, and I know this is a string, right? And I try to assign it to string. Java is gonna complain, okay? Because my list could have anything. I mean, my array list could have anything. It didn't have to have a string. So when in compile time, Java checks the syntax. Java does not even run the program. So Java is not aware that you added TSU. You didn't add, you added computer science. So syntax wise, it will complain because it could have returned anything like an object. So what you can do, whatever it returns, I want to cast it back to string. Then this will fix the problem, okay? And you can get, you know, the first element, which is going to be TSU in this case. Well, so if I modify my example and if I put string here and then a string here, then I don't have to do this down casting right there. Because at compile time, I'm telling Java that my list is going to include only strings. So when I get an element from the list, it must be what? A string. So with generics, you eliminate casting, the need for casting. Now I'm gonna do another example. I'm going to create a class, which will not need any of the util, and I'm gonna go and create a class, and I will call it data structure. So I wanna create a data structure by myself, and I call it data structure, okay? And data structure, I'm defining it in a general sense. It has a data member called of type object, and then it has 2 methods. One is public void set, which takes an object as input, let's say data, and it simply assigns the input to the data member of the class. And similarly, I have a get method which returns an object. Okay, it simply returns data. All right. return data. So I have a user-defined data type, data structure, I call it, one data member, two methods. Okay, very simple. Now I'm gonna go and create an instance of this. I can say data structure. Okay, data structure. Let's say my data structure is equal to new data structure. So I created data structure, and then let's look at this. Can I make a call to set method like this? My data structure dot set, and then I say maybe new string, okay, TSU. Is it possible to do that? Well, it is, because what did I do here? I created a string object, but a string object is an object. So this is a valid input, and then the data member of my DS is going to be set to what? String TSU. So there's no issues here. So what I'm going to do, I'm going to convert this, but now what if I want to restrict, what if I develop something that's going to enable me to be more precise at compile time. So let's go ahead and modify this a little bit. Okay, so I'm going to go first add a T here, capital T. That's a common naming convention. Capital T stands for type. Instead of object, I will deliver it as capital T. This is lowercase t. I put capital T. Of course, you can do any naming. It doesn't have to be T or lowercase. It has nothing to do with, and then I say this dot T is equal to T. And I say, instead of object, I get this data type, and then return T. Oops. So as you see, I modified my data structure. It used to take object. It had a data type object. Now I'm saying, I don't know the type yet. I don't know the type yet, okay? Then I define my data structures, for example, like this, integer. And then my data structure, integer. Now, what does this say? Okay, I'm going to create an instance of data structure. However, my T will be what? Integer class. So my data member will be type of integer. When I set it, I'm setting an integer. When I get an integer. So this will be an error now, because now I'm trying to add a string. But at compile time, Java knows that data structure should take an integer object as input. So this is going to be what? An error. It's not going to compile. So let's try to compile. Let's clear this for a second, and then I compile. As you see, it says string cannot be converted to what? Integer. So that's going to be a compile error. By the way, you don't have to put integer on this side. I mean, you can remove that. This will be still what? Fine, as long as you put integer on this side. Okay, that part will be fine. So what did I do here? I created a generic class. A generic type is a class or an interface that is parameterized by a generic statement or generic data type. Okay. All right, so let's move to the next example. All right, this time we are going to use multiple parameters. So I'm going to remember the map that we discussed. A map takes a pair of data. One is the key, the other one is the value associated with the key. So it is like key and value pairs. First, I'm going to create an interface, and I'm going to call it IMap. And that interface will take two generic types, K and V. By the way, K is for key, V is for value. That's a generic, that's a naming convention. And then I say K get key, and then I have another one, V get value. So my interface has two methods. One is get key, the other one is get value. Depending on key and V, they will return appropriate values or appropriate types. Then I define a class. I class my map class, I name it, which implements, by the way, I also say that it's going to be parameterized as K and V, and which implements IMAP, and IMAP is parameterized by K and V, okay? So this is my class. Of course, it's going to be capital K. So I'm going to define two data members, let's say private, okay? And then I say key, and then private, and then I say V value. So it has two data members. They are all private. Then I will provide a constructor, public my map class, which takes two input arguments. Okay, and it will say this dot key is equal to key, and this dot value is equal to value. All right, so that's my constructor. And let's add two methods. One should be public, okay, and then K. I'm gonna override those two methods simply, okay? And if you remember, in an interface, all the methods are public, so when I override, it needs to be overridden as public. So it should simply return key. And then I will have another method, public V get value, and it's going to return value. So now I repeat, I have an interface and I have two parameters. And then my map class also has two parameters because it implements IMAP, and I parameterize everything here. So I'm gonna go and create an instance of what? My map class, But this time I'm going to send K as a string and V as a string. So that means my key is type of string and my value is also type of what? String. I will say map1 is equal to new my map class, okay? And here string, and this one is string, okay? So, well, this is not like that, sorry. It's going to be angle brackets. And then I may say, for example, let's say I'm going to do TSU as the key and Nashville as the value. So that's what I created. And then if I go and say system.out.println and map1.get value, for example, is supposed to return what? Nashville. Okay. So let's go ahead and run it. Unless we have an error, it compiles, and then we run it and we see Nashville. Now this is K and this is V, the type. But what about if I create another map, this time string and integer? The types cannot be primitive data types like int, double with lowercase d, okay? They have to be objects or classes, integer. And now instead of Nashville, I put what? 615. Now, second time when I create my class, K is string and V is what? Integer. So if I go and print map2.get value, it's going to get 615. All right, let's compile again and let's run. As you see, Nashville, first one, and then 615. You see how useful it is? I mean, I don't have to fix my key and value types at compile time. Okay, so let's move to the next example. All right, in this example, basically we create a class with generic types. Now I'm going to create a method with generic types. So first, let's get rid of this interface. We don't need interface in this example. Let's get rid of that. And let's keep everything the same, just like a method, just like a class like that. And let's create this time integer map1, and let's say this is also 615. So I created map1 and map2. Both of them are the same kind of, I use the same way to create map1 and map2. Now, also, here, I'm going to create a method, public, static, okay? And then the method is going to have two parameters, k and v, and it will return a Boolean. And let's say method name is compare. I call it compare, and it takes my map class, and it takes k and v, and then let's say map1, and it takes another my map class, okay, my map class. There's a mistake here, of course. My map class, k and v, okay, and then map2. So this method takes two input arguments, and both of them are type of what? My map class. So now I want to compare them. If they have the same key and the same value, I will say I'm going to return true, because at that time, they are the same, they are equal. Otherwise, I will return false. So simply, I will return, okay, map1 dot get key. I'm going to get the key. If it is equals map2 dot get key. So that's the first thing that I'm going to check. Yeah, so this one equals that. And then and I will do the same thing for value. Get value and map2 dot get value. Okay, so if both keys and values are the same, it's going to return what? True. Now, pay attention, since my map class map1 is created with string and integer, k will be what? String, and v will be what? Integer. So in this case, if I go ahead and make a call to compare with map1, comma map2, it's going to return true. And then let's also print it, system.out.println. Okay, so when I run this program, it is supposed to print true, unless I made a mistake. Here you go, so it prints true. Now, I hope you understand how you can define a method in generic sense. You need to put the parameter list to the beginning of the method, okay? So let's move to the next example. All right, so I extended our previous example, data structure example. We used to have those three. Now I added a method to data structure class called check data. Check data method takes u, that's also generic type, okay? I put u, but I say that u can be anything that extends date. It can be date or one of its subclasses. So I'm telling restriction on u. I'm saying that it can accept objects of date or one of its subclasses. And check data right there. And now I'm going to go, I create an instance of my data structure. I added what? Hello TSU students. So this capital T is what? String. Lowercase t is what? Hello TSU students. Okay, so I just said it. Then I say my data structure check data new date. Well, check data. This is new date. I'm going to go to check data method. It takes you, and you must be what? Either date or one of its subclasses. Is this okay? Yes, because that's date class. Then I make a call to check data again, but this time I send a string. Is this okay? No, because string is not a subclass of date. Okay, so with those wildcards, no, it's not wildcards, sorry, with those kind of restriction, you can tell what you can be. Okay, so let's move to the next video. All right, so in this example, I'm going to show you can have multiple bounds or multiple restrictions. For example, I have class car, I have an interface iCar, I have another interface iStudent, and I have a class which has a parameter t, but I say t is something, okay, it can be car or one of its subclasses, or it can be iStudent interface or one of the classes that implements iStudent interface, or it can be iCar or one of the classes that implements iCar. Okay, so that these are the bounds for what? T. And note that the car is the only class. You can have only one class. You can have multiple interfaces, but the first statement after extends should be or must be actually the class. For example, here after extends I say iStudent, that's going to cause a compile error. Okay, let's go to the next. Okay, so I created a simple example. Again, I have my data structure and I say data structure number. Number is a class. The integer class extends number class. Double class also extends number class. So an integer is a number, a double is a number, but a number is not an integer, and so on. So when I create data structure, I say number. That means my uppercase T is what? Number. So that means my data structure is going to keep the data, lowercase t, can be assigned only what? As a number. So can I assign a new integer? Can I create an object like this new integer and assign it to number? Yes. Why? Because an integer is a number. So this will be okay. And this will be also okay. And first I assign lowercase t to 20, and then I assign the lowercase t to what? 25 with this set. So when I compile and run it, I should see 25. Run it, I see 25. By the way, those strike through again, because that method is deprecated. So I'm going to put number 25.0. Again, 20 is not primitive type int. What Java does, Java is gonna go and do this for us. Java will implicitly will create this object for us, okay? So these two are equivalent. So here, what did I do? I say, if the generic type is number, you can assign any element or either they are number element as long as it's a number or one of it is subclass objects. Okay, so let's go to the next example. Okay, so in this example, I created a method for you. Public static void method, and method takes a data structure object as input, but it says that the data structure object that I'm going to have will have number as the generic type. Okay, so that's what it says. Let's create a data structure, myDS. As you see, that's a data structure and the generic type T is integer here. We know integer is a subclass of number. But even in that case, if I make a call method with myDS, myDS is data structure with generic type integer, but the method requires a generic data type number. Even though integer is a subclass of number, in other words, integer is a number, this is totally different. We are talking about the whole data structure itself, not the elements of the data structure. okay? So when you put the whole data structure as input, it must match exactly the same thing. So this is integer, this is number, it will not work, okay? Be careful in this example. However, now I'm going to use upper bound wildcard, okay? And question mark represent unknown type. So we are gonna write a method that works on lists of number or subtypes of number. The same example as previous one, but this time instead of number, I put this one. What does it mean? So that means this method can take an object of data structure as long as the generic type is either number or one of its subclasses, it will be okay. Since my DS is a data structure and the generic type is integer, which is a subclass of what number, so this time it will not give you a problem. Okay. So let's see the next. So now I'm going to use another wildcard, exactly the same method here, but this time lower bound. It says question mark super integer. This means any class, either integer or one of its superclasses. Integer or one of its superclasses. As long as you create your data structure with the generic type T, and T is either integer or one of its superclasses, you'll be fine. Now I create my DS with integer, and I send my DS as an input argument to methods. Well, integer. So integer is there, so I'm fine. Or I create another data structure object. This time I use number as T. Well, number is a superclass of integer, right? So this call is also okay. Then I create another data structure with double. Well, even though number is a superclass of double, number is a superclass of int, integer and double have no, sorry, number is a superclass of integer class, integer and double have no superclass subclass relationship. So you cannot send my data structure 3, my DS3 as input to this method because it does not satisfy this condition or lower bound requirement. It should be either integer or one of its superclasses. All right, so now we can have a little more formal introduction. Okay, these are the examples that I already did type for you. I mean, you can skip this part of video if you felt comfortable with the objects, with the examples. But let me very briefly tell you what I did. I created a hash set. A hash set is a set which is not sorted. Therefore, which is not sorted, that means I can have different kind of objects in this set. First, I add a string, and then I add another string, and then I add an integer object. Again, this 20 is not int. This is Java is going to do auto boxing, and it's going to create new integer parenthesis 20 for me. When I print my set, it will print 20, TSU computer science, it will compile, and it will run fine. However, when I change hash set to tree set is sorted. In other words, all the elements are required to be what? Of the same type. However, compile time, Java doesn't check. Java does not run, actually. So it will first add a string, another string, and then an integer object. It will compile. But when I try to run it, it's going to complain. It's going to throw an exception, class cast exception. It will not be able to convert this integer to a string. Okay? They must be of the same type. And in order to solve this problem, what I did, and when I create tree set, I put angle bracket string here. When I add, at compile time now, Java is going to check whatever I am adding must be a string. In compile time, this satisfies that, this satisfies, but 20 does not satisfy that requirement, so it's going to complain. So you have stronger type check with what? Generics. Okay. Now we also eliminate casting, the need for casting. For example, I have a list, my list, and array list. I add TSU, I add computer science, and the first element of the list, index 0 is TSU, index 1 is computer science. Even though I have TSU as a string, compile time, Java checks the syntax. My list is simply an array list. An array list can hold different kind of objects. So whatever it holds may not be what? Assigned to a string. So Java is going to complain this way. But you have to do explicit casting, downcasting, so that Java will not complain now. It's going to say, okay, my list can be any of the objects, but it will know that I am pushing Java to make sure that it is treated as a string object. So this will be fine. However, if I add this string there and this string there, at compile time, Java knows that my list can hold strings. Therefore, when I say get 0, Java will know that it is a string. So I don't have to do casting there. A generic type simply refers to a class or an interface parameterized over types. So this is the example that I put. I created a, first of all, let's forget about the generics. In general, I may define a data structure and which may have a data member of object. It may have set and get methods just like this. Then I can create an instance of my data structure, and then I may add an object. Well, object is a superclass of all classes. That means a string is an object. When I create a string object, I can easily, I can obviously send it as an input for set method. So this will be fine. So I'm going to convert this to, instead of working with general objects, I'm going to convert it to a generic type. So I will say data structure has T as generic type, okay? And I replace object with capital T and data with lowercase t. And then when I create my data structure, I have to specify the generic type for this particular class. For this particular class, the generic type is integer. So this creates my data structure 1, and then also, I don't have to have this integer there. I can just have angle brackets, okay? In coding, maybe I forgot this, but yeah, you have to have angle bracket right there. Then when I say my ds.set new string tsu, that's gonna be a compile time error. Why? Because it's expecting to have what? An integer object, which is not an integer object there. Okay. T stands for type, and capital T, that's typical naming convention. It doesn't have to be T. And multiple types, parameters, this is what I did. I said, how about if I have not just T, but if I have multiple? And for example, when we discuss collections for maps, maps contain a pair of data items. One is key, the other one is value. In this one, I define an interface IMAP with 2 parameters, K and V, 2 abstract methods, and I have a class. I say class will have K and V as well, which implements IMAP, which has K and V, and I do implement get key and get value methods like that. And now when I create my map class with string and string, that means K is string, V is string. That means my key will be a string and my value will be a string. And I create an instance just like this with angle brackets here. So key is TSU, value is Nashville for map 1. And then I create map 2, this time string and integer, key is TSU, value is 615. When I say get value, it's going to print Nashville. When I say get value, map 2 is going to print 615. Okay. So now how can I define a method, generic method? This is my generic class, and this is my test. I define a static method. For methods, I have the angle bracket at the very, very beginning. First, I say for compare method, K and V are what? Generic types. It will return a Boolean. It will take map1, it will take map2, and then it checks it gets the key for map1, and if it checks if it is equal to what? Key of map2. Similarly, value of map1 is equal to value of map2. Then it will return true. Here, since, sorry. Okay, it's going too fast. Now I have map1 and map2 the same. In this one, the same key but different what? Oh, no, sorry. I go here, the same key, the same values. So it's going to return what? True. And bounded type parameters, that's what we talked. For example, here I have my data structure, and then I have a method check data, okay? And for every method, I have to define the type, generic type at the beginning, right? When I define at the beginning, I say my generic type will be U, but U can be either a date class, it may be class date, or one of it is subclasses, okay? So basically this does not much. It gets the class name for T, it gets the class name for U. So now I create data structure with what? String. That means capital T is what? String. And then I say my ds.set hello TSU students. That means my U is here what? A string. So I am adding hello TSU students. Sorry, I'm adding hello TSU students. That means my capital T, I mean lowercase t is what? Hello TSU students. Then I say check data, and I say data takes U, and I create a date object. Well, U can be date or one of its subclasses. So this will be fine. But if I make a call to check data with Nashville is a string. Well, U will be string, but string is not date or one of its subclasses, so it will be compile error. You can have multiple bounds. For example, you can have this class special, okay, which takes T as parameter, but there is a bound, multiple bounds. That means T will be a class, either car or extending car. It may be iStudent interface or something implementing that, or it may be iCar or something that implements iCar. But you can have only one class, and the class must be the first thing. Okay, so here we said that I have data structure, and data structure generic type is what? Number. That means I can add either a number, I can add a number to this data structure. Since integer is a subclass of number class, when I create an integer object, actually I'm creating a number object. So this is fine. Similarly, double is a subclass of number class. So when I create a double object, actually I'm creating a number object. So this too will be what? Fine. And first set method is gonna set this T to this 20, and then it will set it to 25. So when you run it, you will see 25.0. Okay, now there's a little difference here, and I have a method says data structure and number. Look, method is looking for the whole data structure, and the parameter of that data structure should be what? Number. Now I create a data structure whose parameter is what? Integer. Okay, and when I pass this as an input argument to this method, I will get an error. Because I'm not talking about the contents of that data structure. I'm talking about the entire data structures. They must match. However, I can use wildcards, like upper bound wildcards. When I say here, I say the input can be a data structure, and the parameter of that data structure or generic type of that data structure can be number or one of its subclasses. In this case, I will be fine because integer is what? One of subclass of number class. And also we have lower bound wildcards. The same thing, this time method can be taking either integer or one of its superclasses. Okay, so when I create integer, that's fine. Number, that's fine, because number is a superclass of integer class. But double is not a superclass of integer class, so this will be what? An error. I guess you are motivated for generics. Generics were introduced to Java with 5.0. And they are mainly used to make collections type safe, as you have seen. Arrays are type safe. They can contain only of the same data type, but collections do not have to be type safe. Okay? For example, here, I may have a list, like array list, And I may add a string, that's fine. I may add an integer object. I may even add a car object. Car is a dummy class I defined here. No problem. However, if I define list with this angle bracket string, I can add a string, but when I try to add anything other than string, I'm going to get an error, okay? Okay, so let's pay attention here. I have car, Honda extends car. Sometimes the common sense logic is not gonna work, okay? Be careful. So I can create a list, an array list of cars. No problem. This is car, this is car. I can have Honda, Honda, no problem. However, these two sides must match. This cannot be car, even though Honda is a car. This is different because it's not gonna be, components of the array list in this case. I'm saying that list 3, so basically you cannot have here car, here Honda, or vice versa, okay? However, for arrays, that's not the case because this says that I'm going to have an array of 99 objects and arrays of type car, but each component of the object, each component of the array is gonna point to a Honda object because Honda is a car, so you don't have that problem there. Okay, so now let's see what this does. Let's be careful. Again, car, Honda extends car. I have method 2. Method takes a list with car as the generic type. Method 2 takes a list. It can be car or one of its subclasses. So first I create an array list with car and I can pass ls to method without no problem because this is exactly what it is looking for. Then I also, and I create a Honda object as you see here. I mean, an array list that holds Honda objects. If I pass it to method, I will have a problem because this is looking for list of cars, but this is list of Honda, so it's not gonna be okay. However, if I pass it to method 2, it looks for either a car or one of its subclasses. In this case, Honda, and I will be fine. Okay, this is another important thing that you have to be very careful. You can stop the video from time to time, okay? Because some of the concepts are really important for you to take time. So I have this method the same as before. I have method 2 the same as before. What does method 2 tries to do? Okay, compile time and runtime are two different things. At compile time, method 2, Java thinks, okay, method, as long as I have car or one of the subclasses, I'm fine. Now, inside method, I am trying to add a new Honda object. Java is going to complain because method 2 has not been called. Maybe method 2 will be called with Chevy, right? Then I will still try to add Honda. Maybe the intention, if this is Chevy, then I can add only Chevy objects at that time. So at compile time, Java does not know what the generic type of list will be. So Java will refuse to add Honda, okay? And I create a car list and then I send it to method, that's perfectly okay. I create a Honda list and I send it to method 2, that's perfectly okay. But inside, I cannot specify a Honda object. Okay, however, okay, now let's see. This time, what did I do? This was car or one of its subclasses. At this time, subclasses may be Honda, Chevy, BMW, it may be something else other than Honda. However, if the wildcard is like that, it says it can be Honda or one of its superclasses. Okay? So I will be fine to add Honda in this case. Why? If it is Honda, a Honda is Honda. If it is one of its superclasses like car, a Honda is a car. So that means adding Honda is also okay there. And there's no way that this can be Chevy. There's no way that can be BMW because Chevy is not a superclass of Honda. So there will be no problem here. And we have list question mark. List question mark means any type, okay? So you can say list question mark list is equal to new array list Honda. That will be perfectly okay. But you cannot use wildcards here, okay? And list question mark is different than list object, because this list object means only object class objects, but this wildcard here can refer to any object. Okay, let's see. All right, I create a list of array list. This is perfectly okay. By the way, I have vehicle, car extends vehicle, Honda extends car. Okay, I created those. And let's go to this list object, list 6, array list. This is also okay. And list object, you see both sides must be the same. So this is not okay. You cannot have wildcards like this. You cannot have wildcards on this side. You can have wildcards on the left side. It says vehicle or anything, a subclass of it. And you cannot have two different types there. And even though this is okay, it will give you a warning because you did not explicitly put what? The type on the other side. So now we are going to go a little deeper. Can we have user-defined generic classes? Yes. Okay. So let's pay attention on this example. I have class student, and then I have graduate student, extend student. Then I define a class called grade generic, and the generic type is T. And it has one data member called grade list. And it has a constructor, as you see here. Constructor takes a list as input and assign that list to data member generic list, grade list. And then get grade returns this grade list. Add grade simply adds a new list to grade list as grade list. Okay. Sorry, it's gonna add a member to the grade list. This one. Now I create a graduate student array list. Okay, so a list of graduate students. I create one graduate student, another one, I add them to the list. No issues, because list can hold graduate students, and I created two of them and I send them to the list. So list has two graduate students in it. Then look at this, grade generic. And then what is the T this time for this grade generic? The type is going to be what? Graduate student. So whenever you see the T, you should replace it with what? Graduate student. So your grade list is a list of graduate students. Okay. And I create using a constructor that takes list as input. So I'm going to go here. So now I have a grade list. Grade list is a list of graduate students. And I send ls as input to the constructor. That means list is ls. Grade list will be ls. And ls contains two graduate students, remember? Then I created a new graduate student. I create a new graduate student and I make a call to add grade. That means this T is graduate student and lowercase t is S3. So I'm gonna go and add a new graduate student to the grade list. It used to have S1 and S2. Now it will also have S3. Okay. All right. This is a simple thing. I have two graduate students, S1 and S2. And then I have a method. When you define methods, don't forget you put the generic type as angle brackets to the very beginning. And then this says TT, that means says type 1 and type 2, both of them are type of T. It creates a list of this T and adds type 1 and type 2. So basically, I create an object of this class. Why? Because main is static, this method is non-static. In order to call this method, I need an object first. I create an object and I make a call to method. And I send S1 and S2. Well, S1 is graduate student. That means this T is what? Graduate student. Replace all the T's with graduate student here. That means you create a new list of graduate students and you add S1 as the first item and S2 as the second item. Okay. All right. So I have another example. I have robot and I have closest object method, which what is the generic type? Capital T. It returns a T. It takes two T objects and basically it returns the first input argument value as output of this method. So I create a robot object and I make a call to robot.closes object, this time 99 and 200.5. 99.0 is not primitive data type double. So it's just like this. Java is gonna do auto boxing for us. It creates a double object and it creates a double object. So what is this T? T is what? Capital double. So replace everything with capital double here and you'll be fine. So, okay. So now let's talk about, I mean, this is like, we are gonna go a little bit back. So I have a list of array list. I mean, it's an array list. I had Java certification, no problem. If you recall, list, the superclass or the super interface was collection, and collection had a data member called iterator, or a method called iterator, and it used to return what? An iterator object. So now I had Java and certification, and I make a call to iterator method of list class, and it returns an iterator, but I say that iterator may be an object. It may iterate through objects, but in this case I say whatever you're going to iterate will be a string. Okay, when I say it1 has next, it checks if the list has any elements, and it will point to the first element, and it's going to get, when I say next, it's going to get it as a string because it knows. It says, if I didn't put string here, it will complain here because it.next is gonna be an object and you cannot assign an object to a string. But if you make this one string, in compile time, it knows that the objects that I'm going to iterate through are type of strings. So that will be fine. And this is, you can safely skip this, but I'm going to explain. I defined a method which returns an iterator object, which takes a list. It first reverses the order of the list, and it returns the iterator. It makes a call to the iterator method of the reverse ordered list, okay? So that's what this method does. So I create, again, Java certification. Okay, this is the first one, this is the second one. I make a call to method by sending this list as input. So list and ls are the same thing. It is going to first reverse the list. So instead of Java certification, the first item will be certification, second item will be Java. And then it's going to make a call to iterator via the modified list. And that iterator will be returned. So instead of iterating from Java to certification, it will iterate through what? Certification to Java in this case. Again, because of the string, this line will not complain. Okay, well, you cannot use for each for iterators. Iterators, you have to use what? Methods of the iterator interface. Has next, for example. You cannot use for loop, not like that, or not like this, even though if it is string, okay? All right, let's see. Linked list, if you remember linked list, that's a list. So first, and linked list expands, it inherits from what? It's a collection, clearly, because collection has list as an interface and collection is the super interface, and linked list is an implementation of list. I had Java certification is easy, okay? But linked list does not sort. There's no sorting. So the first one, second one, third, and fourth. And this method returns whatever collection that I created here. A linked list is a collection. So I can assign a new linked list, a linked list object to collection, as you know. Then I make a call to this method. I make a call to this method and it returns C. I can iterate through the collection objects, okay, this way. So it's going to go to the first element, Java certification is easy, okay, but not like this, not for iterator. Okay, Q. I mean, we haven't seen an example of Q. This is a good chance for us. Q was first in, first out. Priority queue was priority in, priority out. So you can define your priorities with the priority queue. So here, what do I do? And poll. What was poll? Poll means fetch and remove the head of the queue. So here, 99 is added first, then 200 is added second, and 44 is added last. The head of the queue is 44. So when I say queue.poll, it's going to print 44 and it will remove it. Okay, but since this is priority queue and it's not first in, first out, it's going to do natural ordering. Okay, so even though when I add those, the 44 less than 99 less than 200, so this will be the head of the queue. I will see it and I will remove it. Then the second item will be 99. When I pick just fetch it, but it doesn't remove. So it's going to show 44. Similarly, if I do pick first, I'm going to pick 44. I'm going to see 44, but I didn't remove it. When I say poll, I will get 44 again, and I'm going to this time remove it from the queue. How about here? Again, priority queue is going to do natural ordering. JCIE. Certification will be the first. And then easy second is Java, right? So based on the alphabetical order. So when I say poll, the head of the queue will be certification. It's going to print certification and it will take it out. Now I have left with 3 elements and the top of the queue or head of the queue will be this time easy. When I pick, I will get that one. Okay, now hash set. Remember hash set? Hash set is a set. Sets do not allow multiple or duplicate elements. So first I can add Java, then certification, but when I try to add string Java, I will have a problem because when I make a call to equal method, for example, new string Java dot equals new string Java will return true. So it will not be added. This will not be added and size will be what? 2. How about here? Well, let's be careful here. String class overrides the equals method of the object class. But I have a class called car here. I did not override the equals method of what? Car object class. Therefore, even though I'm not able to add Honda twice, the reason for that, since string class has an equals method, and when I make a call to equals method via this object and this object, it will return true, I am not able to add it. However, car class does not have an equals method. So, and the default equals method just checks memory addresses. Since this is an object pointing one memory space, this is an object pointing to another memory space. When I invoke equals method via those 2 objects, it will return false. So it will be able to add those 2. So there will be what? 3 objects in this case. Okay. So let's see, hypothetically, let's assume that we have a class robot implements an interface called comparable, and it implements a method, comparable interface is a method called compare2, which takes an object as input, okay? Let's say that I want to do this as generic. So if I do this, public class robot implements comparable and then angle brackets robot, okay, that means this parameterized type is what? Robot. And if I say public int compare to object instead of, see, that object is supposed to be replaced with what? Robot. Otherwise you get an error. Okay, so this is mainly what I want to discuss with generics. I hope this was clear and I hope you enjoyed it. It's pretty simple. You just need some practice. I'll see you in another video.